Okay, so we have a question here regarding ball bearings, manufacturing, etc. And we're saying that if they're a wrong size, they're going to get rejected. So looking at that question, we can see that if we call the distribution x, we've got the probability that x is greater than 2.4 is 5.5%. And we've also got the probability that x is less than 1.8 centimeters is 8%. Okay, now let's have a look at a little picture of that again. I like my pictures. You have this distribution x thing, you have a value of 1.8, and this little section here then is 8%. Okay, and we have a section over here at 2.4. Again, the sketches don't have to be super accurate, just to give us an idea. And this is 0.055. Okay, so the two translated to mathematics, what we've got is that the probability that z is less than 1.8 minus mu over lambda is 0.08. Okay, so we'll do one thing at a time here. Now, clearly, when you look at the tables, we don't have a 0.08. Okay, so what we're going to need to do there is when we look at it, we're going to say that 1 minus 0.08 is 0.92. So what we'll do on there, on the table, we'll look for 0.92, and there it is. Right, let's look, right there. Okay, so 1.4051. Oh, something there. It's jumped. Okay, equals 0.92. And so from tables, we end up with a value of 1.4051. All right. Again, using that idea of the symmetry, the 1.4051, what we have to use is value of negative 1.4051. Okay, because we're to the left of the mean. So negative 1.4051 is going to be less than 1.8 minus mu over lambda. Okay, now for the purposes of our polysolute, which we'll use later, we're not going to use the less than sign and the greater than sign, etc. We're going to do negative 1.4051 times sigma is equal to 1.8, big bar, plus mu equals 1.8. So what I've done is I've just rearranged that around. Just rearrange that. Sorry about the jumping around everywhere, but that's where we've got to at the moment. So we're just taking it one step at a time. We've looked at one of the possibilities, the scenarios, and now what we're going to do is look at the second part, which is the probability that z is greater than 2.54 is going to be equal to the probability that z is greater than 2.4 minus mu over lambda. Okay, and what we're looking at there is that is 0.055, and the phone's ringing. Thank you, Daniel. Clearly again from the tables, we're going to struggle with this one here. So what we will be looking at is the probability, instead of it being greater, we're looking at it being less than. for the tables is going to be equal to 0.945. Okay, and that one's an easy one to look at. It's straight from the tables again. Okay, so if we look at the tables there, looking for 945, 94, and then 5 will be 1.598. So we've got 1.592 is equal to 2.4 minus mu over lambda. This will imply then that 1.598 lots of plus mu equals 2.4. And I know this is a long way around of doing it, but I think it's useful to see what's exactly happening. We then go to Polysmelt on the TI-84 and we tap in the values on the Polysmelt, and you can see there on the left that's been done here. And then when we do alpha solve, we end up with two results here. So x1 is equal to 0.200 if we're going to do 3 significant figures, and x2 is equal to 2.08. Okay, so what's the question asking is, assuming that a ball bearings are normally distributed, what is the mean and the standard deviation? Alright, now the way that we put that in was standard deviation came first. So the mean and the standard deviation, the mean is the second one and the standard deviation is the first one. So that's, can't remember what they are now. First one 0.2 and 2.08. So 2.08 centimeters and what was it? 0.2. Okay, and 0.2. Okay, that's done, and that's a tricky one.